going to start with a song, and now I won't. Stole all my thunder. But I'm going to talk about the environmental impact of regular clothes and shoes, like what we're all wearing here today, thankfully. Although, I should disclose, I am picturing all of you naked right now. And you look good. So, it's nice for me. The title of my presentation is Wasting Clothes Warms the Globe. And I'm going to cover 4 topics. It's very difficult to see, but the first one is, why do we care about global warming? Second, the connection between waste and global warming. Third, the potential in textiles specifically. And then finally, what are the benefits from diverting 90% of textile waste, which is basically the definition of zero waste. And over the last 100 and some years, the concentration of carbon dioxide in our atmosphere has been increasing dramatically, from about 280 parts per million when the industrial area started, to passing the Rubicon of 350 parts per million in 1986, which is when we were locked into future climate change, reaching 400 parts per million last year around this time, and now we're a few parts over 400. And we know that we're going to reach about 500 parts per million by the middle of this century. This is what's driving the global warming. And this graphic, it shows how the temperature has increased since about 1900. And in the beginning, you don't see much change, but as we get into the later half of the century, here we're in the 70s, 80s, 90s, 2000s, and we end in 2011. 2012 was actually the hottest year on record so far. We can also see it in the extreme weather events. Here is a graph that shows the number of record high temperature events compared to record low temperature events. In the 50s, it was about 1 to 1, but by last decade, the ratio was 2 to 1. So 2 record highs for every record low. Last week was a good week for reports on climate change. So I've included a few slides from a new report that was released on Tuesday last week by the White House. It's actually a very good report. It talks mainly about the effects that we can already see. You don't have to go far into the future to see dramatic changes. And this map, it shows the change in very heavy precipitation over just a few decades. So as you can see in the Northeast, they're the most severely impacted. 71% increase in heavy precipitation. This map, again, it's very difficult to see, but it's billion-dollar weather climate disasters in the last 30 years. And Texas, all of the southeast, the northeast, Midwest, very severely impacted. And since we're in Atlanta, let's take a closer look at the southeast. And the report is great because it gives you region by region what can you expect. And here for the southeast, of course, a major concern is the coastal area and vulnerability to sea level rise. So here you can see where there's a very high risk. And the Intergovernmental Panel of Climate Change, the IPCC, they have been releasing these reports. They're on their 5th report this year since 1988. And every time they have to increase their projections because scientists tend to want to err on the side of caution. And so far, their projections have to be upped every time they come up with the new report. So they are already projecting between 1 and 4 feet of sea level rise by the end of the century. But just this week, there were 2 new reports telling us that the West Antarctic ice sheet is collapsing. And that will add another 4 to 12 feet to those projections because that was not included. With less than 4 feet of sea level rise, many urban centers in the US are at risk, like New York, Miami, New Orleans. So very severe impacts. And then this one shows a low scenario and a high scenario for expected temperature change by the end of the century. So anywhere from 3 to 4 degrees to 15 degrees is what we can expect. And that's 15 degrees. That's huge. This is a graph that disturbs me a great deal. On the left, you can see the kind of black grayish area. Those are the actual measurements. That's the temperature increase that we have seen in the last 100 years. And then we have 2 graphs going forward. We have the blue graph that shows a trend if we cut back dramatically on our emissions of greenhouse gases. And we have the red that shows what happens if we don't cut back as quickly. The disturbing thing is that the 2 lines are parallel for the next 20 years, which means even if we stop burning coal and oil and gas today, temperatures are going to continue to increase the next 20 years as if nothing happened. So that doesn't mean we shouldn't do anything. The effects are already among us. We, of course, see the natural disasters that impact thousands of people. However, most of the people who are impacted, like Ib was saying, are the poor, and already today an estimated 400,000 people die every year from climate change effects. And they're not dying from climate disasters, they're dying from malnutrition, diarrhea, and malaria. Those are the 3 main killers. And as you can see, it's mostly in Africa, it's in Southeast Asia, it's in South America. So what's the connection between waste and global warming? Well, If has anyone seen The Story of Stuff? A few people. It's a great little movie made by Annie Leonard, and in this movie she explains how our society, our linear economy, generates a lot of waste. And that waste is linked to almost 40% of the carbon impact in the US. So what about textiles? Well, textiles actually is responsible for 10% of the global carbon impact. And that's because it takes a lot of energy to extract the material, to manufacture the clothing, and transport it to where it's going to be used. So if you look at the life cycle analysis of clothing, and I'm not going to go through all the details, but the bottom line is that, that about 15 pounds of CO2 can be saved for every pound of textile that we reuse. Here we go. And that's taking into account how much of our textiles are natural fiber, how much are synthetic fiber. So the blended average is about 15 pounds. So how does that stack up against other commonly recycled materials? If we compare it to glass, paper, plastic, well, it dwarfs the other materials. The only material that really compares to textiles is aluminum, which saves about 14 pounds for every pound that's recycled. But apart from that, you can see you can recycle a pound of glass, a pound of paper, a pound of plastic, and still you don't reach the effect of reusing a pound of textiles. And there are many other environmental benefits from reusing and recycling the textiles, like saving the water that goes into textile manufacturing. So Elizabeth was showing the slide of the rivers running red in China because that's the color of the fall. You know, it's the textile industry is responsible for somewhere north of 20% of the water degradation in the world today. And then there's this, the fast fashion trend of consuming more and more clothing, and consumption has increased in this country more than 5-fold in the last 35 years. And still we're only recycling 15%. So this is another graph. I like it and I hate it. It's the consumption in the US compared to the diversion of textiles. So the red mountain of clothing, that's our consumption. And as you can see, after 1980, it really took off. And we're at about 14 million tons of textiles being consumed every year now. And as you can see, the diversion, the green graph, it has pretty much flattened out. So we have a lot of work to do to capture the rest of these textiles. And then finally, I'd like to say something about approaching zero waste in textiles. And there have been several comments about how almost all textiles are reusable or recyclable. And I was very inspired by Steve's presentation, finding upcycling uses for some of these pieces that can't be worn as they are. So our challenge is not in finding markets, it's in increasing convenience for the consumer to drop off the material and in increasing awareness so that you're motivated to recycle rather than throw it in the trash. And convenience is king. Most people will not go more than 5 miles out of their way to drop off clothing. And we have to provide many recycling choices. I picked a red bin because I know nobody here wants anyone to drop off clothing in a red bin. Yeah, we need more collection points in apartment buildings, at gas stations, at schools. I think it was a commentary on my presentation. We have to keep innovating in how we make it more convenient for consumers. This is a very interesting program in Arizona, outside Phoenix, where a recycling company has partnered with the city of Queen Creek, Arizona, and they are distributing weatherproof bags to households. There are 8,000 households in the community. They each got a weatherproof bag, and then they can drop off their textiles with the regular recycling. And it's a pilot program right now, and as it is, it's very expensive. But it's this kind of innovation that may be needed to get us to 90%. And then we have to increase awareness. We have to talk about the benefits of recycling textiles. So if we increase our recycling of textiles from 15% to 90%, what are some of the benefits? So environmental benefits, we would save a whole lot of carbon emissions, equal to taking 40 million cars off the roads. And in this country, we have about 250 million cars. So that's pretty significant, almost 20%. Save a lot of water. Actually, enough water to supply every household in the US almost twice the annual consumption of water. Of course, the water wouldn't be saved here. It would be saved in Bangladesh, in India, in China. And a lot of landfill space. Economic benefits, well, we would create a lot of jobs. Our industry creates 85 times more jobs per ton than the waste industry does. So over 100,000 jobs would be created, green, local, sustainable jobs, if we increase diversion to 90%. And then we have the social impact, because by far most people in the world today wear used clothing. And here is an idea. What do we do with all those cotton fields that are no longer used to grow cotton? Well, we could plant trees and save another 25 million cars off the road. So a quick recap. Global warming is linked to our linear, wasteful economy. We have to replace this with a circular economy where stuff gets reused, repurposed, and recycled. Textiles outpace most other materials when it comes to how much carbon can be saved by reusing and recycling it. And it is possible to recycle 90% of textiles. We don't have to innovate new uses or new markets. We can reuse it as it is. We can downcycle it to wiping rags or insulation material. We can upcycle it to something new, trendy, and fashionable. And we would save enough carbon to take 40 million cars off the road by doing it. So that was my quick presentation. Any questions?
How could you see it from 15% to 90%? How would you, what could we do to get that to 90?
Yeah, so I think, to be honest, I think the number is higher than 15% today. I don't think that is a good number. Maybe we're at 30 or something. Just looking at how many thrift stores are in this country and how much clothing they consume alone. But even so, it's a big jump to get to 90%. And I think a lot of people, they don't, maybe don't realize they don't know that the environmental impact is so severe of throwing clothing in the trash. That's one thing. And then you have the convenience factor. So if you can, I talk to people all the time who drive around for months with bags of clothing in their trunk. And then they have to put something else in the trunk, so they pitch the clothing because they didn't happen to come by a bin or something else. So making it convenient, making it as commonplace to recycle your textiles as it is today to recycle your paper or plastic or glass, where you're basically doing it at home every week and it's a habit. It's not a habit for people today to recycle their textiles.
Thanks. Can you explain a little bit more about the CO2 savings from the diversion of textiles from the landfill? Does it come from, are we assuming that means we're not producing new material, or just could you talk a little bit more about that?
Yeah, so the number I presented, that's based on replacing manufacturing. So instead of going to buy a new piece of clothing, you buy a used piece of clothing. And then there are some studies on what is the replacement ratio, because you're getting a piece of clothing that's maybe 1/10 of the cost or 1/20 of the cost of a new piece of clothing. So do you buy 2 shirts then instead of 1? And so that's an unknown, and I haven't figured that into that number. But there are studies ranging from 1 to 2 to maybe 75% replacement ratio. But this is basically savings from not having to grow the cotton, from not having to manufacture the new clothing. Then there are also savings from the methane emissions from landfills. That's not figured into this.
Would you speculate on why that pilot program in Arizona is costly?
Yeah, so the bags are very expensive because you know the average garbage truck, you throw everything in the back, it's compacted, and if you commingle the textiles with other recyclables, you have dirty cans and bottles, and it's all in there. It's going to be wet, it's going to be sharps, and so you need a bag that can protect the clothing, and that's expensive. So that's why. And as we know, this is a penny on the pound business, so there isn't a lot of margin in the clothing. So that's why it's very challenging to make it work. We work with a city in Minnesota that has been doing curbside for many years, but they have been doing it on specialized trucks where they have a separate compartment on the truck for the textiles. So that works, but the trend is to do single stream recycling where you put everything in one blue bin and the contents of the blue bin goes in the truck, and that's very challenging for textiles.
My
Like